You guys back. Welcome to your favorite pre-calculus course. Let's take a look here at another example. Let's let negative 2, 3 be on the terminal side of theta. Okay, and we're going to find the sine, cosine, and tangent of theta. And as I mentioned, you want to make these things visual whenever possible. So let's draw this. If we go to the terminal side, okay, so we're going to rotate this thing. So if we're starting here in standard position, right here, we rotate this theta. Here's our terminal side to that negative 2, 3 right there. Okay, so here's our theta that we rotated. So now you want to still create your reference angle, your theta prime, and think about this using right triangle trigonometry. Okay, so let's go ahead and make this go straight down, create that 90-degree angle there. And we say, you know, we went negative 2 this way and up 3. And again, you have to kind of jimmy rig that. I know it's a distance of 2, but we're still going to name this negative 2 for purposes of our cosine and such. Okay, because we know our cosine is negative in that second quadrant, whereas our sine is positive. Okay, so we name this theta prime, and we're going to use theta prime to find the sine of theta. Okay, and the cosine and the tangent. So here we go. Let's go sine of theta, cosine, tangent. Okay. Now you notice we don't have our hypotenuse yet. So go ahead and use the Pythagorean theorem to find your hypotenuse. Of course, it's 2 squared plus 3 squared equals, we'll call that hypotenuse c squared. So you got your 4, 9, c squared. So c is the square root of 13 here. Okay. Let's go ahead and write in square root of 13 right there. And now we'll say sine, cosine, tangent. Oh heck, another hour of algebra. So sine is opposite over hypotenuse. Okay, so now you're looking at theta prime. So opposite that theta prime is 3 over hypotenuse root 13. So 3 over root 13. And of course you want to rationalize that. So 3 root 13 all over 13. Okay. Cosine would be adjacent that reference angle theta prime over hypotenuse. So negative 2 over root 13, rationalize that. And finally, tangent of algebra, opposite over adjacent, 3 over negative 2. You know, take that negative up top there, so negative 3 halves. Okay? So the sine is of that angle of theta is 3 root 13 over 13, the cosine and so on, and the tangent so on. Okay? But you notice this is not, you know, you have this point negative 2, 3. This is not on your unit circle, is it? Because you notice your hypotenuse. You know, how big is your hypotenuse there? That root 13? Well, that's somewhere between, you know, you think about the square root of 9 is 3 and the square root of 16 is 4. So root 13 is somewhere between 3 and 4, so 3 point something there. Okay, so yeah, this is a little bit, if you were to draw this as a, you know, a circle, it's a lot bigger circle than your unit circle is. Okay, so kind of thinking about that, you can now find um, sine, cosine, and tangents of something, you know, larger than a unit circle. Let's go ahead and do another example here. Let's say, let me escape out of this. Alright, so let's take a look at this problem here. So we have the sine of theta is 4/5. Okay, so our y value is 4/5. So we're thinking, well, I got to either be in quadrant 1 or quadrant 2. Okay, if I was to draw this thing. Okay, where does this theta rotate into? But then my tangent is negative. My tangent's negative. Now remember, tangent is sine over cosine, right? Definition here. So if it's negative, and we know the sine's 4/5, so our sine is 4/5, that's positive. So then you're like, well, if this thing's negative, it's got to be a positive over a negative. That cosine is going to have to be negative. So you think, oh, okay, I've pinpointed this thing. I know it's got to rotate into quadrant 2. Okay, so I have rotation somewhere into quadrant 2. Again, because my sine is positive and I have that requirement that my tangent be negative. Okay, so I've rotated in, and then they say, well, the sine of this theta, I'm going to go ahead and create a theta prime, a reference angle. Okay, and they say, guess what? Sine of theta is 4/5, opposite over hypotenuse, right? So opposite over hypotenuse. You do the old Pythagorean theorem and you figure out that this is a 3, 4, 5, right? Isn't 3 squared plus 4 squared equal to 5 squared? Sure. But then you got to run the little trick, right? I have negative x, so I'm going to say, oh, I got to make this a -3, right? We have to do this little Jimmy rig trick so that our cosine ends up being negative, and of course our tangent ends up being negative when we use this. Okay, again, our little Jimmy rig trick. So don't forget that's got to be negative here, okay, before you do everything. Okay, now let's do our right triangle trigonometry here. So we're going to find our cosine of theta is what they're asking. So we say adjacent over hypotenuse, -3 over 5, right? Of course, the cosecant, cosecant theta, which is 1 over the sine, and we already know the sine is 4/5, don't we? Right, so of course we just simplify that. So we got this 5/4, the cosecant theta. This is the reciprocal of sine's 5/4. So what if they asked us to find the tangent? I know they don't on this problem, but you could do that easily. The tangent's opposite over adjacent. 4 over -3, or -4/3. Okay, so there's your tangent. You could find anything you wanted for that reference angle theta, and we don't even know what theta is. We don't know how much that's rotated in this case, right? But we can find all those trigonometric functions for that. Okay. All right. What about um? Let's think about interesting situations here in our unit circle. 0, 0. You know, what if we were finding things like the cosecant or the cotangent and so on at certain points like 0, if we rotate theta, 0 radians or pi halves or pi or 3 pi halves, okay? So if we were to evaluate cosecant theta, and let's do the cotangent theta at theta being 0, theta being pi. Of course, we can continue on, but you'll kind of get a feel for this here. So let's do cosecant of theta. Cosecant of theta, and let's let theta be 0 radians first of all. Okay. Well, cosecant's 1 over the sine. So you have to think to yourself, okay, I have rotated on here, I've rotated nothing, right? So I'm right here, so you're thinking about this point right here. So right here you have to say, well, the sine of theta, let's go back to the unit circle here, is the y value. Okay, right there. So it's 1 over 0. So the cosecant is undefined. when theta is 0 radians, right? Now what if, let's do the cosecant for theta being pi halves, okay? Cosecant for theta being pi halves. Well, I say now I'm going to rotate pi halves amount, right? 90 degrees. My y value there, because I'm looking for the sine here, the sine is 1, so 1 over 1. So the cosecant of theta is 1. What about if theta is pi? Now the cosecant, what's the y value at pi if I now rotate to here, right? 0. So 1 over 0. So again, I'm undefined here, right? The cosecant of theta when theta is pi, so the cosecant of pi is undefined. What's the cosecant of 3 pi halves? So let's turn my cell phone off here. What's the cosecant of 3 pi halves? Well, the cosecant of theta, or the cosecant of 3 pi halves, when it's 3 pi halves, is 1 over the sine of 3 pi halves, or 1 over negative 1, negative 1, right? Kind of get this here. I mean, you could do the cotangent too, where it's cosine over sine, but I'll leave it at that. You can see, you just want to think about those. You're not applying your reference angles and so on at those specific points. Okay. All right, so let's go ahead and look at this here. Let theta be an angle in quadrant 2, such that the sine of theta is 1/3. Such that, you know what? Let me change this just a little bit. Let's make the sine of theta negative 1/3, and let's go into quadrant 3 actually. Okay, so we're gonna rotate this into quadrant 3. Okay. Now I want to create that 90 degrees. So here's our theta. Right in here, I'm gonna say this is my theta prime. Okay, theta prime right there. So for theta prime, let's name this. So we're gonna go negative 1/3 sine theta. So I'm looking at this reference angle in red here. Theta prime opposite over hypotenuse. Okay, and you want to name that. You want to keep that -1 because you're going down in y value right there. Okay. And now you say, well, I got to find that remaining angle. So -1 squared plus b squared equals 3 squared. So b squared equals 8. So b equals 2 root 2. Okay. So 2 root 2. Now in quadrant 3, I'm going from my origin. I'm thinking, well, I go to the left. So -2 root 2. And then I go down 1, right? To the left, -2 root 2, and then down 1. So you want to name that -2 root 2. You want to name that -1, which we already did. Of course, your hypotenuse is always positive, and that'll make this work out for us when we're using right triangle trigonometry. Okay, so finally now we want to go, let's find the cosine theta, cosine of theta, which is adjacent to theta prime over hypotenuse. So -2 root 2 all over 3, already rationalized, done. Okay. Now what if they asked you to do this exact same thing, but by using trig identities instead? By using trig identities instead. They say, well, I have the fact, I know that the sine of theta is negative 1/3, right? And I'm in quadrant 3. Okay, and since I'm in quadrant 3, I know my cosine also has to be negative. So if you're going to use that trig identity, think about the old money formula. Sine squared plus cosine squared theta is 1, right? You use this all the time. So negative 1/3 squared plus I don't know what cosine squared is. And then I finish this, 1/9 plus cosine squared theta is 1. I subtract 1/9 both sides. Of course, this is 9/9, same thing as 1. Subtract 1/9. So cosine squared theta equals 8/9. Square root. Cosine theta is plus minus, that's 2√2, square root of the top over square root of the bottom, right? And I say, wait a minute, I'm in quadrant 3, so I know my cosine in quadrant 3 must be the negative 2√2 all over 3. Okay, and that's how you could use a trig identity to do the same thing as we did previously with the reference angle there. Okay. All right, a couple more here. I want to make sure that you can, you'll make sure on your calculator that you can get these same answers here. I'm going to use a calculator, the TI-89 here to go. First of all, I'm going to find the cotangent of 375 degrees. And then I'm going to go ahead and find the sine of negative 4.1. Just make sure that you guys can get the same solutions here. The secant of 3 pi eighths. 3 pi eighths. Okay, we're going to do these three real quick. Let me go over to my desk here with my calculator. All right, first of all, the cotangent 375 degrees. I want to make sure I'm in degrees, and I want to go cotangent. So I'm going to go 1 divided by, and put this in parentheses here, the tangent of 375. Just like that. 1 divided by the tangent of 375, 3.732. Okay. Now the next one, the sine of negative 4.1, there's no degrees on there, so I want to make sure I'm in radians. Okay, so again, I changed my mode, do this in radians. The sine of negative 4.1 is 0.818. Okay, and finally the secant's 1 over the cosine. 1 over the cosine, and then I got 3 pi eighths. 3 pi eighths is 2.613. Okay, and you could have also gone secant, so you could go catalog with that, secant, and again punch in that 3 pi eighths, 2.613. Okay, same thing. Thank you very much. See you next time in class.